Myself, S. Mohammad Ashik, I will explain the Bellman-Ford algorithm. Bellman-Ford algorithm helps us to find the shortest path from the source vertex to all other vertices in a weighted graph. Now, what is the difference between Dijkstra's algorithm and Bellman-Ford algorithm? Bellman-Ford algorithm takes into consideration the negative weighted edges, whereas Dijkstra's algorithm does not. Here, in this example, the weight of the edge between node C and node D is minus 4, which is a negative edge. Whereas in Dijkstra's algorithm, the negative weights are not allowed. Now let us see how this Bellman-Ford algorithm works. Firstly, we will be given with a weighted graph. Let us assume our source vertex to be A. Our aim is to calculate the shortest distance from a source vertex A to all other vertices in a weighted graph. Now, what is a shortest distance when we start from a node A and again come back to node A, which is nothing but 0. So, we updated the value of source vertex to 0. Let us assume the shortest distance from a source vertex A to all other vertices to be infinity. So we update the value of all other vertices to be infinity. Now let us see what is the shortest distance from node A to node B, which is nothing but 0 plus 4, which is 4. 4 is less than infinity, and this is the shortest path taken to reach the node B. We update the value of node B to 4. Similarly, we shall start from a source vertex A to the vertex C. The shortest path is 0 plus 2, 2, which is less than infinity. So we update the value of node to 2. The corresponding graphs look like this. Now our aim should be to calculate the shortest distance from a source vertex A to the vertices D and E. We shall first calculate the shortest distance to reach E, then we shall go for D. You can even do vice versa. Now there is many possible ways to reach vertices D and E. We shall take each path. We shall consider this path first. 0 plus 2, 2. 2 plus 5, 7 is a one possible solution to reach vertex E. We shall look for some other alternatives. 0 plus 4, 4 plus 3, 7, 7 plus 5. No, this is not a possible. This is a possible solution, but it is not a shortest distance. We shall look for some other alternative. 0 plus 2, 2 plus 1, 3, 3 plus 3 is 6. So 6 is less than 7, 6 is less than 12, 6 is less than infinity. So we will update the value of node E to 6. Now we shall calculate the node value of D. We shall take the similar steps to calculate the shortest distance. Let us take this path first. 0 plus 4, 4. 4 plus 2, 6. This is a one possible solution to reach the node D. We shall look for some other alternatives. 0 plus 2. 2 plus 1, 3. 3 plus 3 is 6. 6 minus 5 is 1. So 1 is less than 6. So we update the value of node D to 1. So the corresponding graph look like this, and the corresponding table is this, where we have shown the shortest distance from the source vertex to all other nodes. First we have initialized the source vertex to 0 and all other vertices to infinity. In the second iteration, we just updated the node value of B and C. In the third iteration, we wanted to calculate the shortest distance from source vertex A to D and E. So we found out the shortest distance. In the fourth iteration, we again looked into the graph whether any other possible shortest distances are possible. If the distance is short, so we updated the value of the vertex d to 1. So this is a final table which we obtain when we apply Bellman-Ford algorithm. Now let us see the time complexity of Bellman-Ford algorithm. Now we have to relax E edges. E edges, which means the total number of edges, and 4 vertices in this case because we are not including the source vertex. So the time complexity will be order of V into E. Whereas the time complexity of Dijkstra's algorithm is order of E into log V. From this, we can conclude that Dijkstra's algorithm is much faster than Bellman-Ford's algorithm. The major disadvantage of Bellman-Ford algorithm is that it cannot be used when we have negative weights on an undirected graphs. Now let us look into some of the applications of graph theory. The major and an interesting application of graph theory is in Google Maps. Suppose I want to move from Singapore to Tokyo. We will consider the Singapore to be one node or one vertex and Tokyo to be another vertex and the distance to be the weighted edge. Here the most popular algorithm used is Dijkstra's algorithm because we are not using any negative edges here. This completes the Google Maps application. The second application is in food delivery app. As we all know, in the food delivery apps like Zomato, Swiggy, etc. Here we consider one of the node as the restaurant, other node is our home, and road as the distance. Here the algorithm to be followed is again Dijkstra's algorithm because we are not considering the negative values or the negative weighted edges. Let us look into some of the other graph theory algorithm. Dijkstra's algorithm we have dealt in the previous section of the video. Kruskal's algorithm helps us to find the minimum spanning tree. Now what is this minimum spanning tree? The edges and the vertices which we consider should form a tree-like structure and the distance from the source vertex to all other vertices should be minimum. Prim's algorithm follows the same algorithm as Kruskal's algorithm, but the major difference is that in Kruskal's algorithm, we start our traversing from the root node to find the shortest distance, whereas in Prim's algorithm, we start our traversal from the newly updated shortest distance value, which is nothing but a node value which has got the minimum shortest distance. And next comes the Bellman-Ford algorithm, which I have dealt in this video. The next algorithm is Hofcroft-Karp algorithm and Edmonds-Karp algorithm. Both of these algorithm is related to bipaired graphs, which means a graph which contains a set of edges and vertices. We will segregate a set of vertex to one set of independent vertices V1 and other set V2. And it should be noted that every edge of a graph is mapped from the V1 vertex to the V2 vertex. The next algorithm is Trajan's algorithm, which helps us to find the strongly connected component. The strongly connected component mean if we start from one node, after one cycle, we should be able to reach to the same node. The next algorithm is Floyd-Warshall's algorithm, which is the most efficient algorithm. This algorithm helps us to find the minimum shortest distance from the source vertex to the corresponding node. This is the most popular algorithm known now. It is valid for both directed graphs as well as undirected graphs. Now the implementation of both of these algorithm, Dijkstra's algorithm and Bellman-Ford's algorithm, will be dealt in the later section of this video with then demonstration of an app